Hi, so I want to show you how easy it is to get started with a blinking LED in PSHDL. First, you're going to visit the website like pshdl.org. I'm going to the beta website because it has some features that are required for actually getting the code run on the board. So on the Learn tab, you will find some introduction on how you can get some blinking LED in PSHDL. And then there is a code tab where you can actually get started with coding. But before you start coding, you have to create a workspace. So there's a create workspace button, and here you enter some email, like this. And then you want to create a new file. So I'm just clicking here. You can choose from a number of examples that are available, but we will just stick to the default. So the default is already a blinking LED, which is of course very convenient for me because I don't need to edit anything. But this is a 20-bit counter of an unsigned integer, and I'm taking the 20th bit and put it out as an LED. And I want to simulate it to see if that is actually working. So I can run a simulation in the browser by clicking on the simulate. And if I run it now, I can see that this is working as expected. So, but let's go back to the blinking LED. So we want to actually run this on the board, and for this we have to compile it to VHDL, and this is done by clicking on the compile button. And so here you can see that this looks like really regular VHDL code that you can use in almost all tools from all vendors. In order to get it running on the board, we need to first specify a board that we want to use. So we will use the PSHDL board, and we call it PSHDL. And here you can see some features of the PSHDL board, like there is a clock, and you can see that this clock is running at 32 MHz. And there is also a reset, which has the same pin as button 0, but this one is inverted because the button on the board is active low. But the reset that is used by PSHDL is by default active high. So the next thing is that we need to specify that we want to synthesize something. So you want to use PSHDL board, and we want to have the blinky module that we just defined, and we will specify it in a file called synthesis. So now you have a file where you specify that we want to use the blinky top module, and we have the ports LED, clock, and reset. And now we just have to specify where we actually want to place it. And so I will just take the green LED on the first arm. And for the clock, I'm taking the clock. And for the reset, I'm taking the reset. One of the cool things is that you can actually see where those are. So here you can see that this is the button for the reset. This is the button for the LED, and the clock is coming from the Atmel on the other side. Of course, you can also create a constraint file that you can use with every vendor tool that you will find. So in order to get all of this running, we need to compile again, and then we go to the Run tab. So what you can see here is that you need to have a local client. This local client is actually can be downloaded from this website, and it's available for Windows, Linux, and Mac OS X. I already downloaded the Mac OS X version, and now I'm going to launch it. So this is the window that you have for synchronizing a workspace. You copy the workspace ID and you put it in some directory. I have a directory where I put all my workspaces, so I just use this and this. And what this does is it synchronizes all the files from my workspace to my hard disk. And another advantage is it's also It also knows that on TTY USB Modem 1 there is a PSHDL board and there is a FPGA programmer interface. That is the software that is needed for uploading the programming file to the board. So now that we have this running, we also need to specify. We also need to attach some compiler to this workspace, and I can do so from my Windows computer here. In the future, this will actually not be necessary. So you will be able to invoke the synthesis from the web interface without having to run this locally. So what I did now is it created the bit file that is used for configuring the FPGA, and it also prints out what was given by the tools on the command line. And if you're interested in that, you can also check out the report where you can find all kind of detailed information. For example, the estimated frequency or what the logic path is and stuff like this. So, but now we want to get it run on our board, and for this we click on the download button. So now the board is configured and we have a blinking LED. It's that simple.